Shall we make? Okay, settled. Right. Good. I mean, at least there are 20 people here. That's very nice. We will make a start. I don't know where the others have gone, but anyway, it's all right. And I was just updating group C. I'll just give you an update on C. So a lot of people were worried and wrote to me about this 24-hour assignment. What they are expected to do, when is it, and all those things. So nothing to worry. It's a simple thing. It is on the 28th of February. Okay, 28th of February, as per the outline given. So basically, you have classes on 28th. You will obviously be here. You finish at 4:30. I'll be taking your class, and then I'll give you enough time to get home, and then at 9 o'clock, I will upload the case. It's not a big case; it's just 2 pages. No, you don't need to break your head. At 9 o'clock, I will upload. Next day, that is Sunday, 1st March, 9 o'clock, you can put it back in the portal, or you upload your answers or whatever that you want, your assignment. So that is 24 hours. You should be able to do it. Now people ask me, it's not enough time and all this. It doesn't matter, right? People do it in 12 hours. You don't need 24 hours, right? So you read the case, go to bed, get up in the morning and start doing it. That's enough time, right? You don't need to worry about it. Plenty of time. But I know some people like to break rest, work through the night, make it perfect and submit. That's up to you. But there are students who have done it in 12 hours and submitted. Okay, so I wouldn't worry too much about it. Okay. But whatever you do, please submit. So 9 o'clock on 1st, 9 p.m., the day of submission, if you try to submit at 8:55, you are not going to submit, because all 400, 500 people are going to try at that time, and the portal clashes. Right. So my suggestion to you is at least by 8:30, 8:20, whatever time, half an hour before, start submitting. At least if you have 3/4 finish or quarter finish or whatever, better to submit and get something rather than not submit and get zero. And if you don't submit it on time, please don't email it to me. I can't read it. I don't read it. Not allowed. Okay, so it has to come through the portal. And the portal will shut down at 9. Okay, it's automatic shutdown. So please be mindful of that. And don't wait till the last minute to upload, because you will have problems. The laptop will crash, internet wasn't there, portal is too busy, you saved the work, but it didn't get saved. All those issues are there. So you need to be able to plan ahead and make sure you submit. Okay, so 28th February, everybody gets the same case. And then on the 1st, you can submit. The 1st is a Sunday. All right. Any questions on that? I will upload a brief anyway, but any questions on that? No. Okay, fine. So let's move on. Yeah. The other thing is simulation. I can't remember when it is. I think that is also on the 28th. I can't remember. Whatever the date given on the course outline is the simulation date also. I think for you it is the same date, 28th. So you will need to attend anyway. So you need to come here, physical attendance, 100%, and then night you will go and do the assignment. Right. So let's carry on to look at where we left. So last time we looked at project planning, the planning of time, the cost time factor of a project. Well, how do you plan? So we use WBS, then we went on to use critical path diagrams, and then we developed or we looked at Gantt charts, and we understand how a project times are planned. Today, we are going to look at, and by the way, I gave you some softwares to try if you want to try. As I said, you don't need this. You can do it in Microsoft Excel. Right. So today, what we are going to look at is the resource plan. So what do I mean by resource? Resource are people. So I'm not talking about other resources, material or, equipment, those things. I'm not talking about those resources. I'm talking about resource planning, people planning is what we're going to look at today. So I give a simple network diagram. So you have activity A, 2 weeks, 2 FTEs. 2 FTE means full-time employees, right? Full-time employees. That means they are hired full-time. Then activity B, 3 weeks, 2 full-time employees. Activity C is 5 weeks, 4 people. Okay. So this is a extract of a larger network diagram. So what happens here is that we have these 3 activities that needs to happen. And if you notice, all 3 of them start at the same time, A, B, and C. Okay. Now, if you want to plot this into a bar chart, you will take activity A, which requires 2 weeks, 2 people. So that is A. Then B has to start at the same time. B, if you see here, 3 weeks, 2 people. So we have 3 weeks, 2 people. So additional 2. Then if you look at C, which is 5 weeks, 4 people. So starts at the same time, 5 weeks, 4 people. So total required people is 8 for this project or this part of the project. Now, if you see there, the total man weeks, if you want to call it, 8 times 5, 40 man weeks are required for this project. So it costs money for 40 man weeks. Now, in the context of things, what we notice is that if you do that, there is some wastage here, unused. This part is not used. So we want to reduce that. We want to reduce that part where it is wasted. So this is called resource optimization. Resource optimization. So how do you do that? There are various methods. It's a simple method. So what you do is you take the largest requirement, in this case, C, which is 5 weeks and 4 people, right? That you can't do anything. You take that on. Then you have A, which requires 2 weeks, 2 people, and you bring in B, which is another 2 people, 3 weeks. So by rearranging, you have saved 2 people worth of resources. So 2 into that's 5 is 10 week man hours, 10 man weeks have been saved. Okay, this is optimizing. So we don't need 8 people. Actually, we can manage with 6 people. Now, what's the challenge with this? What's the problem with this? What are the assumptions? Sorry? I can't hear. Are you talking amongst yourself or talking to me? I just need to be very clear about it. Coming 1 by 1. Right. Can't you see because as a like the just like building, we should do a correct. But we can't start to confuse it. That's right. So what you are saying is It depends on what is the activity. So in this case, I haven't given you. So we are assuming it is all can be done by the same people. So in this case, what we are saying, these activities can be reorganized. That's the first assumption, or can be brought together. The other assumption is that the activity A can start, the B can start after A. Even though here B has to start along with A, we are assuming here B can start after A. It's an assumption. The third part is that even though this is all full-time people, we are assuming these two who is doing A are capable of doing B as well. That's the point he was making. So for example, if you say A is plumbing, B is electrical. Now, a plumber can't do electrical. So in this assumption, we are assuming this A can do the work of B as well, and vice versa. So there are limitations, and we are going to do a real example in a minute, where you will see that requirements are important. Okay, so resource optimizing is a key element of project planning. Right. So this is how a real plan may look like, or part of a plan, where you will have, in this particular extract, you will see there is 31 people or 30 people required resource, and each week how many is required, and you optimize that, you save quite a lot. That depends on the activity. So you don't actually need to hire so many people. You can actually manage with 10 people. That is what we are trying to achieve. Okay. When you do an example, let's look at, right. So here is a simple example I have given. You have cost per day per resource at $10. You have here activity A to F, transport cement, build boundary wall, lay the grass, fix the gates, fix the light, and paint the wall. The activities have been given. Now, if you were to plot this, let's say it is like this. A requires 3 people, B requires maybe 4, plus C has to start at the same time, and so on. So the maximum number of people required here is at this level is 7. So if you were to hire people, you need to hire 7 people, full-time people. You need to have 7 people. And we are saying, therefore, the 7 staff, permanent staff, cost 7 into $10 per day into 10 days is $700. Now, if I were to reorganize, I can say C and D, what is lay the grass, fix the gate. So they were doing that along with B. We will move that further down. So C is fix the gate, lay the grass, and D fix the gate. So that's fine. We can do that here. We move that along. Then you optimize. Now you can see we can manage this project with 4 people. We don't need 7 anymore. So the staff cost would be 4 times 10 times 10. Now is $400. The importance of optimizing resources. But please note one thing for sure. The area under this graph and the area under this graph is the same. The area doesn't change. That means the manpower requirement doesn't change. What you are changing is the number of resources. Okay, you will look at, when we do an example, we will look at that. Okay, I know all of you are tired. I know it's a long day. Final class. I know you just had lunch. You probably 2 hours to go, and you must be tired as well. So, what I thought we will do today is do lots of exercises. Lots of questions. Keep you awake. Yeah? Right. So I'm going to come around and help you. Right. Okay. Here is a, this is exam question, by the way. This was, I can't remember when, but this was an exam question. Now, in this question, the activities were given, then the time is given, the dependency is given, and the resource is given. What I would like you to do is first do only the critical path. Don't worry about the resources. We will do that later. So can you please draw the resource, what do you call it, the critical path diagram first, and let me know how many weeks this project is. And just to let you know, there are dummy activities in this project. So dummy activities are demonstrated with draw. So what is a dummy activity? It's very simple. So let's say you paint a wall, and it takes 3 weeks, right? And then you probably need to do a dummy activity here. Let it dry 1 week. Now, drying a paint wall is nothing to do with us. We don't need to put a resource to dry it. It will dry on its own. There's no activity involved. So, but it is required for the next one. Maybe second coat paint. Right? So without drying, you can't put the second coat. So you need to leave this to dry. So that's a dummy activity, nothing to do. You can go home and come back. But it needs to happen. So you can't, what you can't do is do this. You can't do that. Right? So what you can't do is paint the wall and say, now do the second, paint the wall and second coating. You can't do that. Got it? Okay. If you are not sure, please ask. Okay. When you do this example, you will see that. Please try this. Give you 10 minutes to draw the critical path diagram. Don't worry about the resources. I'll come to that later. Try to do on your own and not take any help. Done. Yeah. Why not calculate that time? Yeah. Okay. Completed. What happened?
Yeah, I do it for me and then evaluate. It's right.
Okay. Okay. Good. Yeah. Okay. Calculate the time. This is the actual exam question, by the way. This was. If you like to try, you can try. You don't have to try. It's up to you. Okay, that's good. Some are yet to start even. That's good. Okay. Good. Okay. Got the answer? Yeah. And where's the end? Okay, you're still doing it. All right, fine. Okay. Okay, good. Yeah, all right. Have you calculated the weeks? Yeah, okay. You done? G1 is dummy. You okay? So these are all dummy activities. So you have to do prototypes. Okay. Let's quickly have a look at it. So A, B, C, not dependent on anything, 2 weeks, right? Okay. So what people do is A, B, C, start, start, start. That's not how you start. You've already been through that. Okay. Always only one start. Start. A, B, C. A is, you can read at the back. Yeah. A, 2 weeks. B, 2 weeks. C, 2 weeks. Okay. A, B, C, 2 weeks. The most of you got that. Then A1, B1, C1. It has no time and it has no resource. We know it's a dummy activities. So dotted lines. So A1 follows A1, 0, A2, B2, B1, 0, C, 0. Okay, I think most of you got that. Then D is A1, B1, and C1. So many had like this. You can't have that. Right? There's only one activity at an arrow. By the way, some of you, very strange, because I never told you that. I think you all are confused with PERT and CPM. Some of you are putting the activity in the node. That's wrong. You can't put it in the node. Arrow is the activity. If you are doing PERT, then node is the activity. Stick to one method. Okay. So D is A1, B1, C1. Okay. D. And D is 1 week. E is 2 weeks, but not dependent on anything, right? So come back to this and start E, 2 weeks. Then F is on 1 week after D. F is on 1 week after D. G is after E, 2 weeks. G after E, G after E, 2 weeks. Okay. G is after E, 2 weeks. Some people can't see it. Okay. G, 2 weeks. Then G1, 0 and 0 again, is after G. So G1, dot lines, after G, 0. Many made it a solid line. H is after E, 10 weeks. So after E is H, 10 weeks. Now, some people draw it underneath here like H. That is also fine. I'm okay with that. But what you can't do is this. Many have that. And many, unfortunately, they think they can do this. In the exam, please turn the paper to landscape and draw it. Very simple. And please do take 1 rupee coins to draw the circle. Okay. You can't do like this and then, put it like this and, go like this and all those things. It's not allowed. Okay. Right. G1 done. H is done 10 weeks after E. And finally, I is when F, G, 1 and H joins. I is after F joins, G1 joins, and H joins. It's I. Clear? And I is 1 week. Finished. End. Most of you got it. I'm not saying no. Okay, that's the diagram. Let's have a look at the forward pass. 0 plus 2 is 2. 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 2 plus 0 is 0, but we have a junction here, 0. This is 0. This is also, 2, 2, and 2. 2 plus 2, 0. 2 plus 2 is 2. 2 plus 0 is 0. 2 plus 0 is 0. So we have a 2 here. I think all of you got that. Then 2 plus 1 is 3. 3 plus 1 is 4. Junction. Let's keep it out. Come back. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 0 is 4. Keep it out. 2 plus 10 is 12. Take the largest number, 12 plus 1, 30. Do the backward pass. Thirteen minus 1 is 12. 12 minus 1 is 11. 11 minus 1 is 10. 10 minus 0 is 10. 10. 10. 10 minus 2, 8. Keep it out because we are at the junction here. 10 minus 2, 8. 10 minus 2, 8. Come back. 12 minus 0 is 12. 12 minus 2 is 10, but we are at the junction, so keep it out. 12 minus 10 is 2, junction. So take the lowest number, 2. 2 minus 2 is 0. So take the lowest number, 0. So this must be correct. Now, let's see where the critical path is, where the numbers are the same. So critical path will be this, here, and here. So critical path is equal to E H I, and project time equal to 13 weeks. Non-critical path are A, A1, D, F. B, B1, D, F. C, C1, D, F. Do we have any other critical path? Or non-critical path, I mean? G and G1. Okay, those are the non-critical paths. Now, how do I know those? Because if I look at the difference, is 8 weeks. If I look at this, 8 weeks. So I know these activities have a non-critical path. Okay. Any questions? Now, you can take a photo, that's fine. The points to remember here in this diagram are where to put the dummy activities. Don't put it as a solid line. Right. Now, the next easy part. So now we have this all sorted out. Now, what do we do with the resource? Now, resource is what we want to calculate next. So, A, B, C, we have 6 resources. D, A1, B1, C1, 0. D is 1. E is 3. F is 0. G is 4. G4. G1, 0. H is 4. And I is 4. The resources. Clear? Right. Now, let's convert this into resource diagram. Now, that is the most difficult part, the conversion part. After that is easy. So, may I suggest a small tip that you all put? Don't write anything. Listen to me, and I will give you time to write afterwards. This is a little bit tricky. So, I will give you enough time. Okay, right. So, now we have the resources planned out. Now, we need to understand where to put them. Right. So, this is what we just drew. Right. Now, this is a resource grid. It's a very straightforward grid if you get the basic rules right. Otherwise, we will get it wrong. So that's why I said, please hear me out. The first rule is the activities go on the left. That is the y-axis. Under pressure, people put number of resources on the left. If you look at this diagram, there is no resources at the moment. We are just, y-axis is the activity, x-axis is the weeks. Here. And we know maximum required is 13 weeks. So we can't go beyond that also. So we know the rule, 13 weeks have been put there. And activities we know from all the way A to I has been put there. So that's the first thing you do. Then the second rule to follow is, and this is important rule, always start with the critical path. When you put the resources down, always start with the critical path first. So don't start with A. So what we know here is that the critical path is this one. Only 3 items. So if we take out of this, what is first is which is the first one is activity E. So we start with E. So we put E down. And how many people are required as per this is 3. And it requires 2 weeks. So we take 2 weeks for for E, and we put 3 people for each of those. So 3 people and each for first 2 weeks. That's it. Now, what is the next critical path is H. So we come down H. H says 10 weeks, 4 people. Okay, fine. So we count 10 from there and we put the 4 people. So 2 is done. 10 means it takes you to 12 and it's 4 resources for 10 weeks. Then final critical path is I. I requires 4 people for 1 week. So I, after this is closed, H is finished, then only I can start. And I starts with 4 people, 1 week. So now we have completed E, H, and I. Now we can go back and see what are the other things. A, B, C. 2 weeks, 6 people each. So A, 2 weeks, 6 people. B, 2 weeks, 6 people. C, 2 weeks, 6 people. Done. Then comes A1, B1, C1. 0 time, 0 resource. So you don't put anything here. This is the third rule. The moment you go and put a number here, even if you put a 0 here, it will mess up your calculation. I'll show that in a minute. So that's why we don't, if it's a dummy activity, we don't put the numbers, even 0 there. Why? Later on, you will see where you need to put the 0. So we don't put anything there, leave it blank. Then comes D. D, 1 resource, 1 week, after A1, B1, C1 is complete. So A1, B1 is complete, which is same as, because it's 0 is same as these A, B, C. Then D can start with 1 week, 1 resource. So 1 week, 1 resource. Then comes F. Now here's the tricky one. Now F says 1 week but 0. It needs a week, but I don't need any people. Because it needs 1 more week, I need to account for that in the project. Even though it doesn't need people, it needs time. Where in this case, we didn't need time or people. But in this case, we need to account for 1 more week in the project. Hence, we clarify here that 1 extra week in this point and put 0 resource. So that week also gets calculated. Okay, right. So F is done. Then come down. G. G takes 2 weeks, 4 people, but G is after E is complete. So E completes here. And then G can start 2 weeks, 4 people. Done. After E is complete. Then G1, again, no resource, no time. Then leave it blank. Then H and I, we have already completed. So once you have done this, if you total these numbers down, not this way, but vertically down, for 13 weeks, you will see for each week how many people are required. So week 1, you need to hire 21 people. Week 2, you need to hire 21. Week 3, 9, and so on. This will tell you at any given time, you need maximum 21 people. Or when I say any given time for this project, to complete, you need to have 21 people. Clear? Right. I'll give you some time to write this down or note it down or take a photo, whatever you need to do before we go to the next step. So let me just repeat the rules. Activity goes on the vertical axis. You start with critical part first for the resource. Where there is dummy activity with zero resource and zero time, you leave it blank. Where there is activity where the resource is zero, but time is required, you need to count that as zero. Okay, these are the 4 rules. Right. If you want, please jot it down. Okay? Not okay. Right. Anybody have any questions on this? Any doubts? This was an exam paper question, 2017, and was worth 25 marks. That is optimization. I'm coming to that. So this is not optimization. This is just a straightforward resource diagram. Okay. All right. So now we have the critical path diagram. We have the basic resource diagram. We have not optimized. So that's the next step. Okay. So as long as you followed the rule to draw this, then you won't get it wrong. Okay. So that's important to the basic rules to follow. Right. So you got this diagram. Now, if a project requires resources, do you know any given week how many people is required? Now, if I were to plot this into a graph, this is how it will look. You don't need, in the exam, I never asked to draw graphs because it takes so much time and you all don't have time. So the graphs are just for demonstration, not for draw. So if I were to plot this into a graph, bar chart, so you will see week 1, 21, 21, and then tapers down. It's a simple graph to draw. Now I want to take this resource diagram and I want to optimize. Find out why I need 21 people. Can I reduce it? So I move on to this again. Please listen to it and then you can do your part. I look at activity A, B, and C and I say, look, if I go back, A, B, and C is the same thing, but different zones. Do a market survey in zone 1, Gampaha, let's say. Market survey zone 2, Nigambu. Market survey zone 3, Colombo. So the skill sets required of these 6 resources is the same. So I take that information. I say, why don't I ask them to do zone 1 first? After that, go into zone 2, and after that, zone 3. So I move the people a little bit further, the resources. But please note, I haven't done anything with the critical path diagram. That remains the same. The critical path resources remain the same. I haven't touched that. Then A1, B1, C1, nothing for us to do. It's just dummy activity. But D says D can only start after A1, B1, C1 finish, which is same as ABC. So A, B, and C has to finish, then only D can start. So earlier D was somewhere here, now the D moves here. Because ABC must finish for D to start. Then E is a critical path. Now comes F, which says D has to finish for F to start. So This is where the 0 is important. D has to finish here, then only F can start. Right? So the F also moves along. Then G, which is down here, G says on E finishes, G can start and H can start. So on G finishing here, on E finishing here, G can start, which is this one here. E finishes, G starts, 4 people, and H starts. So G requires 4 people for 2 weeks, H requires 10 weeks, 4 people. So we start this after E is completed. The 13 weeks doesn't get affected. If you look at the earlier number and now you see the maximum people required is 14 at any given time. So you need to have only 14 people. Why hire 21 people? Right? So that is the purpose of optimization. Now, some people ask me about G. So now you go back to the activity. People ask, G is here. Can I start G anywhere here? Because H has 10 weeks. G is here 2 weeks. This is 0. Therefore, can I ask G anywhere here? So now I go back to the activity and say, what is G? G recruits staff. Therefore, you can recruit staff anywhere along this line. But is that practical? No. You need to hire staff. If you can't go and hire staff on the last week, and if they say, I need 8 weeks notice to join you, then what do you do? So then you must look at the activity and say, okay, hiring staff, I better start early. But I can give them the notice period to join. That is a different thing. I can hire here. I don't have to incur a cost. But I can say, join 8 weeks later. That's different. You can't start looking for people on the last week. So then you must understand what is this activity and where to put it. It doesn't really matter where you put it, but where do you put it? So the important thing to understand is the activity and where you want to put it and how you to optimize it. This is then gives you an optimization of at 14 people and not 21 people. And if you were to plot this into a graph, the orange is the old one. Once you plot the new one, now you know you can complete this project with 14 people. Again, you don't need to draw the graph. Okay, right. I'll give you time if you want to jot this down. Any questions? Some people looking very doubtful. Hey, be careful drawing, yes. you may want to put a red star and keep for optimization. All okay? Not okay. Difficult. Can manage. Okay.
If means approval.
Yeah.
So when the report will start, we after approval before just
That's the question. No, so approval of what I can't remember. Do you mean?
Review and approve.
So PM review and approve is
Is it?
F, is it? Yeah, that is the survey results, not the high. That's why it's in that order.
Started G and G1 from E
So you say that again?
to 1.
Yeah.
Last one.
Yeah. Yeah.
And from E.
Why you can't start here? Is it? What is G? Tell me.
G.
Okay, so G. That if you look at my thing, it will say G can start only after E finishes. So then E has to finish it. Then only G can start. The dependency is E. If you look at my table, it says E to have the table. Yeah, so in G1, G is G and G1 dependent on E completing. The E completing, you can't start G. That's what it says. That's why it is given there. Otherwise, if it's not given, it will be a dash here. Then you can go and like this one, you can go and start at A. Okay. Sorry.
Device this because 7 workers working only this week.
Yeah.
Yeah, but that the more positive is some 7.
Yeah. So the way to look at is, if you want to start a project, the boss gives you 7 people. Boss gives you 7 people. You go and say, I need 7 people to start this project. Fine. So you are going to have these people from day 1 to day finish, 7 people. You have 7 people, go and do the project. Now the 7 people salary has to be paid. 7 people cost has to be taken. If you are doing a contract, then you say, for this period, send me 6. For this period, send me 3. That is different. That's why I said FTE, full-time employees. Right. So if you are doing let's say you are this particular one, let's say this survey, right now, the survey is happening in, let's say, in Jaffna. Now you can't be saying, okay, send me 3 people first. Then next week, send me another 3 people. You say, here is your 7 people, go and do the project, survey everything, the results, now come and present to me. So then the whole cost is with you. Otherwise, you will spend transport 3 people, send them back. Next week, 3 people, send them back. It doesn't work.
You consider them as terminal.
Sorry, sir, for the total project. That's right. Okay. Shall we move on? All okay? Any other questions? Right. So let's move to the next topic. So resource diagram is not, yeah. Sorry, I can't hear. Sorry, what's that? Activity B to the 7th week. Well, I suppose you can. But then how will you start analyzing the data? Will that get delayed is the question. Yeah, so you can start. I'm not saying you can't. I'm not saying we are talking about this, right? So you want to move that to the 7th week here, and so 2 weeks, and then you want to move 6 to the final 2 weeks. I don't see an issue with that. But then if as long as the critical path doesn't get disturbed, you can move around. No issue. You can move these resources anywhere you want. I'm not saying this is the right answer. In project, there is no right answer. Remember that. This is one answer. Right? If you want to take a larger risk, of course you can. No issue. Right? Problem is you all finish with Ravi, then come to my class, and you expect me to give you one answer. That is the issue. Got it? All right. Project management, any answer is the wrong answer, so don't worry. I mean, right answer, sorry. Okay, right, let's move on. Right. One thing I want to ask you, tell me some of the factors you will consider for a successful project. How do you make a project successful? If I give you a question, 5 marks normally, how do you make a project successful? Simple as that. What are the factors you will consider? Time, resource, budget, risk. Most important thing you're not telling me. Huh? Planning. Good planning, right? So for a project to be successful, most important thing is good planning. You can do what quality, cost, time, motion, people, best project manager, all that is good. Bad planning. What do you call it? Sydney Opera House. Right? So project planning is very important. Project charter, very important. Scope, very important. You've got to define those things. Then, of course, there are other things. We have already looked at it. Communication, utmost important. Risk plan, resource plan, and optimizing resources. Budget plan, we are going to look at it next week. Procurement plan, delivery plan, stakeholder management, management information, communication, documentation, and so on. It's a huge list of items. All these factors are important for a project to be successful. Climate change. Now you are talking about my next slide. This is the problem with you all. You all are so eager to learn. I'm so excited to teach you all. Right? So these are some of the factors that is important when you are doing a project. Okay? These are just notes for you. Right. Let's move on. Now the lady asks, sorry, I don't know your name, but what about climate change? What about it? What's so special about climate change? Let it change. So what? I mean, what can you do? Right? Correct. So the important topic to talk about is green projects. So what is green projects? Green projects are very costly. Any projects you do, you must consider sustainability. And I know you all have sort of studied sustainability somewhere else, but I'm talking from a project angle. Sustainability in a project is very important. So let me just give you a couple of examples. 40 years ago, when you all were not born, there was a president called Premadasa. Right? He started 200 factory projects, if you might have heard about it. The garment factory. He's the one actually started the garment industry in Sri Lanka. So he said, go and open 200 garment factories. He's subsidized a lot of things. He's supported with land and all those things. Now, where do you think they open the garment factories? Rural areas. So they took the factory to the villages. Why? Because easy to hire resources and keep them there. But one most important thing while they were moving the factory, they made sure that the factory was next to what? What does a garment factory requires the most, other than the material, labor, machine and all those things? What is the most important raw material garment factory needs? Water. Water. Plenty of water, tons and tons of water. Every factory needs. Why? To wash the plants, the clothes, the things. They had to wash and dry it. So they always open the factory next to a river. Always next to a river in a village. Why? Because river water is free. If they start paying through the tap, you might as well shut down the factory. So they take the river water, they wash plants, they wash machineries, dye, ink, whatever they use, all get washed. And what do they do with it? They put it back into the river. 40 years ago. So what happens? All the fish that goes to the river, all the fish start drinking that water. We suddenly got colored fish. And I am a victim of that. I ate colored fish. And I used to say, I want pink fish, green fish. You can choose also. So we were eating what? Rubbish, dye. So that was bad. So about 20 years ago, just before that, the government brought in a rule. Actually, the government didn't. The buyers, that is America, UK, whatever, the buyers brought in a rule. Your factory must have sustainable outcome. So your factory must be built, take the river water, no problem, put it back after cleaning it. So all the factories have to introduce something called the RO plants or reverse osmosis plants, where the water comes in, you do whatever you want with it, you have to filter it, clean it up, then only you can put the water back into the river. So that was a rule that was brought by the buyers, where they wanted to make it sustainable. So why they didn't do it in the past? What is the issue with sustainability or green projects? What is the big factor? It's the cost. When you do a project, if you have to do an RO plant or several RO plants and do all this filtering and all those things, it costs money. It's not sustainable for the production. But the rule was brought in, they had to introduce RO plants. And now, obviously, they make sure the water is filtered and send it back into the river. So when you have to do a plant like that, it's very important to build in extra costs for sustainability, any projects. Okay, let me give you another example. All of you are aware, anybody works for John Keels here? Then okay. All of you are aware John Keels is bringing a lot of these blue, what do you call it, BYD cars. Okay, if you walk down, everything is BYD. Right? Now, what's the problem with that? E-waste. So in 5 years' time, today is not a problem, everybody enjoying it. In 5 years' time, when the batteries run out of lithium or whatever the power, you can't charge it anymore. What are you going to do with that? You're going to throw that. Where are you going to throw it? Anybody thought about it? No. We will solve that problem in 5 years' time. Let's think about it later. Don't worry about it. So this e-waste or EV waste, the battery charge, what are they going to do with it? They are going to go and dump it in some deep grounds. After 10 years, they start leaking. They get into the food cycle. And our children will start eating lithium leaks. Our generation ate dye fish. All will eat lithium leaks. We haven't thought about it. Some go and dump it in big ships into the Water. After 10 years, it will corrode. Lithium, all this ink, all this carbon, everything will get released into the water. Fish will start eating that. So what happens? So when you do a project like BYD, they must think through the problem. They haven't. So how do they overcome that? So some people obviously build in a small tax component, right? So you charge extra for future whatever you're going to do with that. So you need to save the battery, or you're going to somehow get rid of it. So where would you get rid of it? Okay, so you don't want to put it in the soil. You don't want to put it in the river. Where would you put it? Degeneration. What? Recycle. Okay, if the battery can be recycled, okay. You want to recycle, you have to take the component out and put the new component in. Anybody work for Haley's here? Which department? Cake Hub. Okay, right. What did Haley's do about 3-4 years ago? What did they import? No, Haley's. Advantage. They imported waste. Medical waste. They imported medical waste. Or whatever waste, I don't know what waste, but some waste. 300 containers. Somebody leaked the information. That's how we found out this has been imported. How did it come to Sri Lanka? Some other country was getting rid of their problem, paid money for Sri Lanka, and sent the waste here to dispose. And we bought it. We needed the dollars. I don't know, maybe you were there or not there, I don't know. I don't need to disregard, I don't need to disrespect any company in Sri Lanka. My point is this. When you do something, think of sustainable solutions. There's nothing wrong with bringing e-waste here. Nothing, absolutely fine. You can bring any waste to Sri Lanka. You must then have a plan to incinerate or to burn or to whatever do with it and then convert it into electricity or something. You must have a plan. You can't bring it to the country and just dump it into some land's end or somewhere. You bring it, then build a incineration, make sure it goes in there. So that is sustainable. Not shareholders' money. Don't look at shareholders' profits all the time. So when you're doing a project, always consider some aspect of the social responsibility. Whether it is John Keel's or Haley's, or it doesn't matter who it is, always consider the sustainable part of a project. So what is Elon Musk going to do with the batteries? You know who Elon Musk is, right? Right. What is he going to do? He's a complete nutcase. What do you think he has proposed as solution, sustainable solution for these batteries? Anybody? No? He is sending them to the moon. It's okay. It's okay. We won't destroy our planet. We'll go and destroy another planet. That's okay. What thinking is that? So he thinks he's going to transport all this e-waste to moon. So always when you are doing a project, it's important to think about the sustainable aspects of a project and how to make sure. Of course, you have to spend money. I'm not saying no. That's why people don't like it. You have to spend extra to make it worthwhile. Okay, right. So it's important. I just put a 5-mark question in the papers asking project X, whatever it was, is what they're bringing, but how do you make it a sustainable project? And you write whatever you want. I had to give you some marks and pass you. Right? What to do? Right? As long as you all have been to the right school, I don't mind. Except for Nalanda College, anything is okay. Any school is okay for me. Right. Let's move on. I don't know where the teachers were when I was studying. Right. Critical path method. Now, activity A, 2 weeks. I give you 2 weeks. Now, how do you know it is 2 weeks? How do you know it's not 1 week or 5 weeks or 7 weeks? How do you know that? So, we have a method to calculate roughly what it takes. So, if you take any of these activity, we have what we call an optimal value, a pessimistic value, and most likely value. Then we take that, put it into a formula where we say expected value, which is this one here, is equal to optimal value plus 4 times the most likely plus pessimistic divided by 6. This is the formula we use to calculate the expected value. So that, but when I say expected value, I am talking about the value that I think would be the right value. Now, if you take, for example, your Singaraja project we did, all of you gave me different numbers. Some gave 200, some gave 500, some gave 1,000. What's the right number? There is no right number. That comes from experience, right? So we come up with what we call optimal value, which is the highest risk for this project. I can do it in the optimal, but highest risk. I can go pessimistic, which is the lowest risk or almost no risk. But what is ideal is the most likely. The risk is balanced. So we give a higher weightage for that. That's why we call it 4 times. So when you take that, the optimal, most likely, and pessimistic numbers, and you get this number, it is not average. Please understand the number is not average. So if you take activity B, for example, is 2 optimal, 3 most likely, 10 pessimistic. So if you put that number through, you get expected value as 4. Whereas if you have taken the average, 15 divided by 3 is 5. Right? But here we can manage with 4. So it's not necessarily the average value. So when you are given a task, you will look at the probability of optimal, most likely, which gets the highest percentage, and then pessimistic, and then you work out the expected value. So this can be done by, obviously, the system can do that, but I'm just telling you, you can't just pick a number off the air. It has to be justified. Now, why it is important is that in case your boss comes and says, look, I don't care, I want this done fastest. I don't care how you do it, I want done it well. Put any number of money, but get it done. Then you can say, okay, I will do with optimal. High risk, less time, but I can do it. If boss says, no, take your time, there's no rush for it, then pessimistic. But most likely, or expected value is the right way to go about. So this is just a simple example of there is calculation behind when you do a activity. Okay. Key challenges faced by a project manager. Now, project manager faces a lot of problems in life. These are just some of them, right? The biggest issue is the team doesn't support him. We will see that under HR aspects. Team is split or they don't want to support him or her. Lack of fun, as we saw in the case of opera house where the funding was not there and it dragged on. Mismatch, as we saw in the case of a father making a chair for his son. Mismatch, communication. Stakeholder pressure, right? There will always be pressure to do something faster. So the PM has to handle that. Lack of resources. So if you don't have the right team or right resources, you're going to struggle. Unrealistic targets, right? Which is a biggest issue in any projects. Media, your biggest culprit, and we will see an example later. Motivation, people give up, the team gives up. Then you are stuck. Quality issues will always be there. And unplanned events that will throw a lot of challenges at a project manager. So these are some of the challenges that a project manager may face in life. Okay, right. Let's move to the next topic. Here is an exam question, 2018 or 19, I can't remember. It was worth 25 marks, question number 1. It's a compulsory question, right? So your exam paper is divided into 2 sections, compulsory and not compulsory, because I need to somehow pass you also. I have to give non-compulsory to get you guys through, right? So here is a simple example. Now, when I give a question, I put some tricks in there. Some tricks. Why? Because I don't want everybody to get 25 out of 25. So some has to get 24, some has to get 23. Right? Otherwise, I will be called into the director's office and say, I have leaked the paper. And I get into an unnecessary conversation. So the tricks are there. If you have understood the problem, you understood it in the class, you will overcome them. And you will see there are 3 tricks in this question. And you start doing it, you will realize it. There are 3 tricks in this question. So if you overcome that, 25 out of 25. Otherwise, it's 22. 22 is easy. That everybody gets it. That's not a problem. Right? I'm going to give you exactly 25 minutes. That is till 4:05. And I'm going to run through this question. I would like you to try on your own. This is already in your notes, by the way, so you don't need to worry about this. I would like you to try on your own. Please. This is the last time you will be doing this critical path question with me. Sign of relief, you don't have to do it again with me. Next time that you will be doing this is in your exam. So if you want any clarity, please ask me. Good. Okay, good. Good catch. Good. Okay, good. Yeah. Why 3H? And 5 more minutes. Please calculate the cost. That's more important to me. If you've done it, please calculate the cost. Okay, good. Okay, let's cost. Yeah, that's good. Cost. Yeah, that's the cost. Still. I'm not okay. Okay. You guys okay? Still okay? Okay. Wow. I love the way you all have developed new critical path diagram methodologies. Come, I'm going to write a book on that. New method by the PIM students. Done? Good. Okay. Good. This is the exam, okay? Yeah. Okay. Good. Cost. Can I know the cost? Please calculate that. Don't do this in the exam, yeah? Okay. Right. Okay, good. Good. I'm worried about these new methods you all are using, huh? Actually. Since when did you start drawing critical path diagram downwards? Okay. Yeah. All right. Looks good. 5 more minutes and let's go. Please calculate the cost if you've done it. Okay. How did you get that? How did you get that? Just added the critical path. Oh. So what happens to the other activities? They don't have a cost. Right. What's the cost? Still doing it. Okay. Cost you got? No. After cost?
2009.
8,900. Okay. Okay.
Yeah, 150.
Okay. Good. Okay. Shall we start looking at it? I think most of you have drawn it. So I'm going to use your new method. Lisa has turned to you for help to construct a CPM diagram to work out the critical path and also estimate the total cost. Do a forward pass and backward pass to calculate time of each activity and the total time of the project. 10 marks. Okay. So very simple. Start. A, B, A, 2 weeks. Nice octopus was developing. Start. A, not dependent, 2 weeks. Okay, good. A, not dependent, 2 weeks. Okay. B, C, and D, A dependent. Okay. So B, C, and D, B, C, and D, A dependent on A completing, right? I think most of you got this. 4, 3, and 2. 4, 3, and 2. Then E is on B completing. Okay. So B completes. You start E. 2 weeks. F, C completing 6 weeks. F, C completing 6 weeks. G on D completing 1 week. So D completes. G 1 week. Right? All done? Right. Then G. H is on E completing, F completing, G E, F, G. H is on E, F, G completing. H. New method. Then what do they do? Oh, doesn't work. Sorry. Then new methods. Keep adding. Even clever answer. Make hariyanne. I know H is here. I don't know how to do it. No, this is dummy activities. Fix the problem. Rubbish. You all go wrong, and I please write this down if you are not comfortable. You all go wrong because, and I told you this last time, because you are closing the loop before knowing what to do next. Don't close the loop. Keep it open. Right? Because you don't know what is coming next. Then you won't go wrong. Right. E, F, G complete, E, F, G. Okay. E, F, G completes. And then H can start 2 weeks. Okay. And then finally, I, on H completing, I 1 week. And we have the end. Okay. Now, let's do a forward pass. 0 plus 2 is 2. 2 plus 4, 6. 2 plus 3, 5. 2 plus 2, 4. 6 plus 2, 8, junction. 5 plus 6, 11. 4 plus 1, 5, largest number 11. 11 plus 2, 13. 13 plus 1, 14. Correct? Yeah. Backward pass. 14 minus 1, 13. Minus 2, 11. 11 minus 2 is 9. 11 minus 6 is 5. 11 minus 1 is 10. Okay. 10 minus 2, 8. Junction. 5 minus 3 is 2. And 9 minus 4 is 5. Take the smallest number. 2 minus 2, 0. Same number. That's correct. Critical path. Where the numbers are the same. Critical path A, C, F, H, I. Project time 14 weeks. Okay, straightforward. Okay, so Lisa, turn to you for help to construct whatever. We have done that. Estimate the total project cost now. Total project cost is already given. Just total them up. 800, 0, 300, 300, 1100, book the venue and pay 50% advance, 5,000. So 50% advance, so 10,000. Correct? Yes or no? Mark yourself wrong. When you start doing my questions, I'll give you one tip. Don't read the activity. If you don't read the activity, you don't need to worry about anything. You have the ABCD, you have the rest of the information. Let the activity be whatever it is. So what? Go and pay 50% advance is an activity. Total cost already given. That is another trick I put there. Total cost is given. Now you don't need to do mathematical here. Stick to basics. Don't worry about the activity. Right? It is an activity. Go and pay 50% advance and come. That's it. Total cost 5,000. Right? So make sure you don't make that mistake. So your cost should be 8,500. Yeah, correct? At least by now you should know when I say correct, it's wrong. It's not 8,500. People forget to read the first line because they are so excited with the critical path diagram. They even forgot that I gave them more information. Lisa's cost is $100 per week. And you can't calculate that if you didn't have this information. Project is for 14 weeks, $100, 1,400, 8,500, 9, 10,000, no. 9,900, is it? 7,000? Oh, yeah. 8,900. Now, some people made another mistake. So, number one, confusion was this. Number two, they missed out this one. Lisa's cost. Okay. Now, who think they can't get 10 marks? You think you can't? Oh, you can. First, read the question, will you? Who think they can't get 10 marks? So, batch B, I can take it. They are good. They will pass. Right. Good. I'm happy. Now, explain what is critical path in a project. What is critical path in a project? It's the shortest time in a project. It is the longest time in a project, not the shortest time. Critical path is the longest time in a project. Number two, it is where the activities cannot be delayed. Number three, critical path is where on the CPM diagram, the numbers are the same. So, what is critical path? Show the critical path on this project, which you have done, and how Lisa can shorten the time taken to do this project. So, this go back to our optimal time, pessimistic time, most likely time. So, what given here is most likely time. So, how can she make it faster? Go for the optimal time, where you crash the project. Okay, 5 marks. Third part, explain the slack time in these activities of this project and how she can recognize or reorganize her schedule without affecting the total time. So, they're asking about slack activity. This is your slack non-critical path. Non-critical path are BE, DG. Now, here the slack time is 3 weeks. Here the slack time is 6 weeks. Right? 3 weeks and 6 weeks. Explain what is slack time. What is slack time? It's the excess time available in a critical path method where an activity can be delayed further up to the slack time. Okay, and you will give these 2 examples. How she can reorganize her schedule without affecting the total time. So, total time we know is this 14 weeks. How can she reorganize herself? So, you can say these 3 weeks can be distributed as wished, or the 6 weeks can be distributed as required. Okay, right. Next question. Explain 5 possible risks associated with this project and how Lisa can mitigate them. Now I will read what is this activity. Design the workshop. Send email. Search for venue. Now I want to know what this project is about. All this time I didn't even want to know. Doesn't matter to my life. So tell me the risk. Now I know risk you haven't done with me, but this is not project management. This is common sense. Tell me what are the risks associated. Give me 5 risks. Anybody? Okay. When you're not available, right? Okay. When you're not available, you can't find it. All right. What else? Hmm? Yeah. Let's put it this way. The SLT, that is the senior leadership team, not available. Not all of them are available. Not all of them are available. Maybe cost overrun. Maybe printer not working on the day of printing. Inform CEO of the final agenda. CEO says, CEO doesn't approve the agenda. He says he's not happy. Okay? Right. 5 risk. Mitigate. When you're not available, what would you do? Sorry? Okay. Alternate. Backup venue, have it in mind. Backup venue. So you need to at least look at a couple of venues and keep it ready. SLT not all available. Tell CEO, send a mail, all must attend. No choice. They do, right? Or you check with the SLT before who is available on what date and fix the date. Okay. Cost overrun. Build extra miscellaneous costs. For approval. Printer not working. Make sure you alternate printer available. CEO doesn't approve agenda. Get approval before starting. I can think of hundreds of risks here, and all have to be itemized. Any project is like that. All right. Now, let's assume you are not interested in any of these risks. You don't like it. You can't remember. The exam blank, can't think. What can you do? Put anything. When you caught fire, staff on strike. COVID hits the country. Possible. What's the new one? Novid, is it? And whatever the new one, huh? Yeah, okay, whatever that is. Hit the country. Right? Huh? Lisa, what? Lisa got sick. Okay. Lisa sick. CEO, heart attack. Heavy rain, floods. Tsunami came. Tsunami warning. You write anything you want. These are all risk. Some of them are risk directly related to the project. Others are non-related, but still a risk to the project. Any of these can happen to the project. Yeah. Lisa sick, then you must have a second project manager. CEO heart attack. CEO died, whatever. Have a 2-minute silence and get on with it. Right? So risk, you don't need to study risk. Risk is there in all the projects. Some of them are specific to the project. Some of them are not so specific, but general. It's outside your plan, outside your general risk. Natural disasters, natural causes. Right. Now tell me, who thinks they can't get 25 here? Can't get 25. Is this complicated? Definitely not. So you should be able to get 25 out of 25. At least 24. Yeah, easy. It's not complicated. Right. Okay. Any questions on today's topic? Either resource planning, resource optimization, optimal, most likely pessimistic, challenges of a project manager, risk, questions. No? All right. So assume you all are all good. So I'm going to move on to the next Saturday, we'll be doing cost planning, cost and price planning. Yeah. Oh, yeah. I forgot about that. Right. So that's on Wednesday. Okay. So I am going to see you, some of you, on Wednesday. Right. At least come, at least 10 of you all turn up. At least, I don't want to look empty here. Right. So Independence Day, we have, I don't know the time, we have a class here. So we'll be looking at costing, pricing, and the risk of prices. Okay, right. Thank you. I'll see you.